Good morning, class. We are moving on to the next chapter, the fifth chapter, which is environmental pollution. Okay, so here we are going to talk about different types of pollution like soil, water, air, noise pollution, all those. Okay, in specific, we are going to see about the types, the causes, the effect, and all of them. Then we would deal with solid waste management. How do you dispose urban waste and industrial waste? Then we have certain pollution case studies, and in addition we have something about radioactive pollution or nuclear hazard. All right, so air pollution, water pollution, noise pollution, and the rest have been given as presentation topics. Solid waste management is also given as a presentation topic, and so is pollution case study. So what we are remaining with is nuclear hazards. Okay, so let's start. Okay, now, there is one concept that you have to understand when you talk about nuclear hazard. Now, one term which we always hear with nuclear hazard is radioactivity. We have all heard of it, right? Yeah. So, radioactivity, we always think it is very harmful. Radioactivity is very harmful, is what we all think. But that's not the case. The worst type of radiation or radioactivity is just one of the types listed as per radioactivity. Okay, not all sources of radioactivity are dangerous. So, in general terms, radioactivity means the transfer of energy into space from any source. Okay, when energy is transferred into space through space from any source, we call this as radioactivity. All right. So when do we say that, okay, now we mentioned all radioactivity is not dangerous. So which type of radioactivity is dangerous? Ionizing radioactivity. Ionizing, the forming of ions, right? So ionizing radioactivity is the most dangerous radioactivity which has an ill effect on the environment and human beings. All right. Now back in what is it? Chemistry. Yeah. So we learned about something called as atom. Yes, the basic component of matter, which is called as atom. So in atom, we used to draw the diagram. We used to have a nucleus. Okay, we used to draw further orbits, and we used to place these small circles all around. Now, to refresh your memory, we learned about proton, neutron, and electron. Okay, so this is an atom. There's a circle here, and there are orbits all around. You in this nucleus, in this small tiny circle inside, which is called the nucleus, you will find protons and neutrons. Okay, and something else called electrons is keeping on revolving around it. Yes, you remember we learned about this periodic table. It had some 118 elements. Now it might be updated, but we had those many elements. So how do you differentiate one element from another one? Like how do you differentiate hydrogen from not oxygen, nitrogen? Oxygen is a compound which you get, right? So how do you differ, differentiate between both? No idea? Okay. Now, every element is differentiated with the number of protons, electrons, and neutrons. Okay. Proton and neutron is found in the nucleus of an atom. Protons carry positive charge, neutrons carry no charge, it's neutral charge, electrons have negative charge. Okay. Earlier, sorry, oxygen is an element, not a compound. Oxygen is an element. I'm so sorry about that. Okay. Now, when proton, electron, and neutron is same for say a set of compounds, okay, the number of electrons, protons, and neutrons needed for a compound like hydrogen is for an element like hydrogen, if it's the same, all those atoms which has the same number of proton, electron, neutron, which is specific to hydrogen, all of them would be called as hydrogen elements. Okay, if the number of proton, electron, neutron is the same. Okay, now if there is a difference in the number of neutrons, we call it isotope. Okay, for example, just an example, if hydrogen was having two protons, 2 neutrons and say 2 electrons. I'm not sure about this number, but just an example. So if a particular element has 2 protons, 2 neutrons and 2 electrons, and if you go for another compound, okay, another atom, and you find that protons is there, electrons is the same number, but the neutron number is changing, we call that other atom as the isotope of the first atom. Okay, for example, hydrogen has deuterium, tritium, all those names, which is differentiated because the number of neutrons have been changed. Alright, so nuclear hazards come when there is an emission of energy from radioactive isotopes. Okay, radioactive compounds are there, but when there is a difference in the number of neutrons and when isotopes are formed, and when there is an emission of energy because of the decay of these isotopes, we call it as radioactivity. This radioactivity is dangerous for us. Okay, ionizing radioactivity is very much dangerous for us. Is it clear to you? Okay. Now the thing about this is these radioactive isotopes are highly unstable. In a different way, if you put it lightly, you place it somewhere in the wrong condition, it reacts and the effect is very huge. Okay, now we have different ways, different types of radioactivity which causes an effect on human health and environment. You have alpha rays, beta rays, gamma rays, you have X-rays and many others as well. Okay, so we would learn about each of them in a specific manner. Now what do you mean by a nuclear hazard? Any actual or potential release of radioactive material at a commercial nuclear power plant or a transportation accident. Okay, when radioactive material is released at either intentionally or unintentionally at a commercial nuclear plant or during transportation, that is during transit, we call this as nuclear hazard. Okay, see radioactivity, again it is produced by the spontaneous decay of the I hope it is visible, of the isotopes of some elements whose nucleus is unstable. So these radioactive isotopes are highly unstable. This is why it poses a huge risk. Now we have alpha rays, beta rays, neutrons, gamma rays and X-rays. Now in this picture I've shown through paper which one is obstructed by paper, alpha rays, which one passes through paper and enters the metal sheet, beta rays, which okay, X-rays and gamma rays, you remember those symbols, right, which we used to learn earlier. They pass through paper and also metal sheet, but they are obstructed by thick lead. And the neutron rays, being the most dangerous, they pass through paper, metal, lead and even water or concrete. Okay, so these are the 5 types of radiation. What are the general causes of nuclear hazards? Apart from these pictures, we can divide these nuclear hazards into 2 types. Those which are caused by man-made factors, and the other one which is caused naturally. Naturally, how does it happen? There are certain cosmic rays which we learned regarding space, which might hit the earth in a very huge way. Okay, like your asteroids and any other comets which has left a mark on the earth's surface can result in nuclear hazards. Okay, so when certain cosmic rays which revolve around the space, and one or two of them, if they hit the earth, radioactive reaction is produced. This results in a nuclear hazard. And also on the earth's crust, on the earth's on the earth's surface, you have certain radioactive elements or materials hidden within the crust. So when those materials react, we can say it leads to a nuclear hazard. So emission of cosmic rays and this release of radioactive materials from the earth's crust are the 2 natural forms. Now from our side, okay, how does it count? Because see, most of the pollution, at least 98% of the pollution, human beings have a huge role in it. Human activity has a huge role. So here how, based on those pictures, first when you use a nuclear weapon, okay, that creates a nuclear hazard due to the huge emission of radioactive material. Then nuclear reactors. Now there are certain reactors which are there in and around the country. There are certain which failed like anything, one of them being Chernobyl. Okay, I'll put it in the message on the link about the Chernobyl disaster, which had a huge impact on this. Then we have certain nuclear establishments. These are normally, to strengthen the nation's defense. That is there, but again, it causes ill effect if suppose things don't work out as planned. Okay, so there are certain things which I'll just read out few causes, man-made causes. First, when you mine and process radioactive ores, there are certain radioactive ores which I mentioned are there on the Earth's crust. When people mine it extensively and it is being exposed, say to workers or to the environment, this causes an effect, a nuclear hazard. Then, like I mentioned, in the nuclear power plant or reactors, when you find radioactive material, a wrong and untimely emission of these radioactive materials would cause a nuclear hazards. Then yes, we left out on one, the x-rays which we take for almost every other thing when we go to the hospital. That is very dangerous because uh, the more you take x-rays, the more your cells go old. Yes, cells do die most of the time and others are growing back, but when you are exposed to a lot of x-rays and other waves which cause a difference in your cell lifespan or cell age, this would result in ill health to you. Okay, so when you go to x-rays, those radiation, okay, we are kept in a room, they test us in a room wherein we are not even allowed to wear a lot of things inside, right? We are given a different dress to wear as such. So this is done so that nothing reflects the radioactivity, yes, but as long as you get prolonged to each session of x-rays, this would cause your cells to die very quickly. There would be a point when those cells will not be healthy. Okay, so then use of radioactive materials and nuclear weapons, like I mentioned. So apart from what we discussed, we had radioactive ores and we had certain medical things such as x-rays which would cause ill effect in the future. Yeah. Now, like I mentioned, the Chernobyl disaster, you see this picture with the merry-go-round? You see this? Yes, and this? These are the issues which, or these is a state of a town called Pripyat in Ukraine, in a place called Kiev, wherein in the year 1986 there was a huge disaster. There was a place, there is a place called Chernobyl. There they had a nuclear power plant which had 4 reactors. Okay, the fourth one, during one particular night, was supposed to, all the reactors were supposed to maintain a certain cooling level. But the fourth reactor could not adjust to the temperature. Okay, it started, the cooling effect system didn't have any effect on it. It started increasing heat and finally it had blasted. Now close to 5,000 people were affected. Okay, and for many months together, Ukraine is a place which you find closer to Russia. Even till Russia and other countries, this effect extended. They didn't have any power supply because everything was cut. Millions died, okay, over the course of years. Those effects from radiation were even carried over to generations. So now that place is very much deserted. I'll send you a few links to show it. Some of the images are very disturbing, but still, yeah. Okay. Now, on the environment, it causes massive destruction. Uh, Plants, trees are unable to produce anything. Yeah, they gradually die off, and even if they die, even if a new plant comes in, the radioactive contamination is always there. So this is very difficult because it makes vegetation, they don't let it grow. So this affects the flora and fauna of the area. That is why it is in this state. Even you see the tiny puppies, or those are puppies, right? Huh. Those are still facing the effect. Even if their parents had the initial exposure, it is carried on to different generations. Okay, and this is the nuclear radiation on human beings. I know 2 or 3 images are very disturbing. Those are the ill effects which you find because of nuclear hazards. Okay, and people always tell, right, don't use your phone, or don't keep your phone below the pillow when you sleep, because this still results out in radiation. We have come across videos which say, okay, these phones, these brands do not cause radiation. That isn't true. The general principle on which mobile phones work emits radioactivity. Maybe the level is less, more, I'm not sure. The claims can be true or false, but it causes a huge effect on your nervous system, on your brain. This would result in prolonged illness. Now, you need to know about certain things, such as mm, there are other, the general effects of nuclear hazards. First one, what nuclear hazard normally does is, we are all composed of DNA, right? DNA also helps in testing out whether correctly who are our parents, who are our siblings, all those. If suppose someone goes missing and they are found later, in order to establish the direct relation, DNA tests are being taken, because those are mostly accurate, would help you in finding the lineage. Now what radioactivity does is, it alters this DNA compound. It alters your genetics. Okay. When it alters, say you're faced with radiation, it alters your genetic thing, and when you have your own children, you will find the effect over there. Okay. Now radioactivity can be found in somatic manner and genetic manner. Somatic is where, for example, if I am exposed to radiation, I will bear the effect, the complete thing, and I will fall sick, and maybe death, whatever be the thing, I'll be facing it. Genetic is where the radioactivity gets passed on to my generations as well, to my kids as well, their kids also. Okay, so somatic and genetic. Is it clear to you? Okay. Now when radioactivity tries to break in through your DNA, it alters the DNA. This would lead to radiation being transferred from generations to generation. Okay. Now, if you have low levels of radiation, which is between 100 and 250, people normally suffer from fatigue or nausea, vomiting, and all that. Those are the general effects. If the dose increases to, these are too many scientific figures, so I'm just saying it, 400 to 500 radiation levels, what happens is, this affects your bone marrow, your immunity system fails, blood won't clot anymore. Normally when we get hurt, blood clots, right? That won't clot. Slowly, the person would develop infection, and finally they may die, or excessive bleeding. So those are your 400 to 500 radiation levels, which cause effects on your bone marrow, on your blood, on your immunity, etc. Now the highest dose, which is 10,000 radiation levels and above, they kill the organism. Okay, so for what it actually does is, it tries to eat away all the tissues of the brain. Now these things might seem too gruesome to you because of all the details that I'm giving, but this is the effect which you have on humans and plants, so you need to know about this. Now those workers who are working in nuclear plant, they are exposed to continuous radiation. Maybe you won't see the effect now, but later they will suffer like anything. Okay. Now how do you control this? How do you control this? You can always check the reactors in a nuclear plant, whether they are having any leakage, whether the cooling system is working. In order to avoid another disaster like Chernobyl, they'll have to work on this. Then what you can do is, the mining which is undertaken in those places for radioactive ores, that can be reduced. No extensive mining, no making the, and even if you have mining, do it in places which is far from the residential areas. People should not suffer because of it. Is it clear to you? We had another nuclear disaster in 2011, Fukushima. Because of the tsunami and all that, you remember? You guys might be in school only. Me too. Yeah. So there, those reactors were very much closer to the sea, situated very much closer to the sea. So when the huge waves came in, they tampered with the system over there. Neither could the workers get out. They were always stuck in the factory. So you need to work on your location as well. Go for places which are, feasible. Those are the things which organizations should take care of. Now, there you can dispose the nuclear waste. Now there are three type of waste. We have high level waste or HLW, medium level waste or MLW, low liquid waste. Okay, high level waste is normally your fuel, unused nuclear fuel. What you need to do about this is you cannot dispose it immediately. Okay, you would have to solidify the fuel. You will have to, the owner producers or the industry people have to store it for, like, in some safe area for 10 decades and decades of years, and only then they can dispose. These are very high reactive waste. The unused nuclear fuel would cause a huge issue, so rather you have to solidify it and store it for decades together. Then you have medium level waste. Medium level waste are those parts of a reactor or a component. Now what you do with this is, those waste are taken, they are mixed with concrete, okay, solidified, and what companies do is, what big shots do is, they try to find a area for them, that is a chamber sort of thing below the sea, and they store it there. That is how they dispose it off. Now what's the third type? That is low liquid waste, which is basically your solids or liquids which are contaminated with this. So what they do is, rather than putting it on the sea, these are low level radioactive waste. So what you can do is, you can find certain areas, certain passages or trenches which is filled with concrete. You can immerse all these materials, all the solids and liquids which are contaminated with nuclear waste, mix it up with concrete and store it over there. This is how you dispose nuclear waste. Alright, if there are any questions, let me know. Please answer the MCQs. We will do the presentations once the class starts. That's in 2 weeks time. Alright, certain concepts relate to science. That is why I'm referring the book. If you have any other questions, do let me know. See you. Bye.